let's see the image formation by convex lens. The rules. A ray of light from the object, parallel to principal axis, after refraction from a convex lens, passes through the principal focus, on the other side of the lens. As you can see here in the diagram, a ray of light which is parallel to the principal axis, after refraction, will pass through the principal focus that is on the other side of the lens. A ray of light, passing through principal focus, after refraction through the lens, will emerge, parallel to the principal axis. This is the second rule, that a ray of light that passes through a principal focus, and after refraction, it will become parallel to the principal axis. A ray of light passing through optical center of a convex lens will emerge, without any deviation. Now let's start the image formation. The first case, when object is at infinity. So here is a convex lens and the object is at infinity. So when the object is at infinity, we see the rays of light coming from the object are actually parallel to principal axis. And all the light rays that are parallel to principal axis, after refraction will pass through the focus, or say will pass through the principal focus on the other side of the lens. So here the two refracted rays actually meet, at f2. So we say, the image is formed as f2. Since the two light rays, or say the two refracted rays, are actually meet at this point, so we say the image formed is real image, and the size of the image is highly diminished. Or say, we can say the image is point-sized. Next case, when object is placed beyond 2f1. So here is our object AB. Now, which is placed at beyond 2f1, a ray of light parallel to principal axis from point A, will pass through the principal focus on the other side of the lens. Now, for the image formation, at least two refracted rays are required. So we take the second ray, from point A, to be passed from optical center. And it will pass undeviated. And these two refracted rays, actually meet at this point, and we draw the image A-B'. So the image is formed between f2 and 2f2. It is real and inverted image, as the image is formed by actual meeting of two refracted rays. And the size of image is diminished, or we can say the size of image is smaller than the object. When object is placed at 2f1. Here is our object AB. Now ray of light from point A, of this extended object AB, goes parallel to the principal axis, and after refraction passes through the principal focus on the other side of the lens. Now again to form an image, we need at least two refracted rays. So the second ray from point A, we take the ray that is passing through the optical center, it will go undeviated. And now, it actually meet, at this point. We call this point, here, as the image of, point, A, of extended object AB. So we draw image A-B'. So we can say the image as formed at 2f2. Which is real and inverted image, as it is formed by actual meeting of two refracted rays. And, it is of the same size, as the object. When object is placed between 2f1 and f1. So here we are having an extended object AB, and now it is placed between 2f1 and f1. We take the first ray from point A as parallel to principal axis, and after refraction it will pass through the principal focus on the other side of the lens, that is f2. Now, the second ray passes through optical center. It will go undeviated, and it actually meets the original reflected ray, or say the first refracted ray, at this point. We name this point as the image of point A, that is A'. And now we join this point perpendicular to the principal axis, and we draw A dash B dash, that is the image of object AB. The image is formed at beyond 2f2. It is real and inverted image. And it is magnified, that is larger than the object. When object is placed at f1, the same object AB is now placed at f1. A ray of light parallel to principal axis will pass through their principal focus on the other side of the lens, and the second ray of light which passes through optical center, it will go undeviated. And we see that these two refracted rays are actually parallel to each other, so they will meet at infinity. So we say the image is formed at infinity, and it will be highly magnified. Here we will not talk about real or virtual, we will just say the image is formed at infinity, which is highly magnified. When object is placed between f1 and optical center, the first ray of light from point A, that is parallel to principal axis, after refraction, passes through the principal focus on the other side of the lens, that is f2. The second ray of light which passes through optical center goes undeviated. Now, this is the divergent beam. So they are not going to actually meet. But for the observer, who is seen from this point, what he will see, that these two rays of light appear to come from this point. So, these two refracted rays appear to meet at some this point. And we draw a perpendicular from this point to the principal axis, and we will say this is their A dash B dash, which is a virtual image of the real object, AB. So we say the image is virtual and direct, and it is magnified. Here is a summary of image formed by convex lens. When object is at infinity, the image is formed at f2, which is real and point-sized. When object is placed beyond 2f1, the image is formed between f2 and 2f2, which is real and inverted, and smaller in size. When the object is placed at 2f1, the image is formed at 2f2, which is real and inverted, and is of same size as that of object. When object is placed between f1 and 2f1, then the image is formed at 2f2, which is real and inverted and magnified. Now object is shifted towards the lens more, and now it is placed at f1. And the image is now formed at infinity, which is highly magnified. Again, when object is shifted towards the lens more, and now placed between f1 and optical center, now the image formed is vertical and erect, that is magnified, and is on the same side as the object.